Okay, having a look here at success criteria E, which is about expanding algebraic expressions. What we're going to have a look at here is like this example up the top, where we've got A and we've got a bracket and we've got a series of terms inside there. We want to do away with our brackets, and the way that we're going to do that is by using what we call the distributive law. Okay. Now, to expand these set of brackets, and it might not make too much sense to begin with, but as we get down through these examples here, it will start to make a lot more sense. What this says is this A outside is multiplied by everything inside the brackets, okay? Because we don't write it because math teachers and mathematicians are lazy, but there's a little multiplication sign in between the A and the brackets. It's just like you would have seen things written like 2A in the past. That is written as 2 times A. It's just that this way here is easier to write. So we do it with that without the multiplication sign. So looking at this says A multiplied by B, which is going to get me AB. And then we're going to go A and multiply it by the C, which is going to get me AC. Okay, now that's the distributive law, and that's what you're going to apply for all of these examples as we work through them here. First one, let's get cracking. We're going to take the 3 outside and multiply it by the first term inside, which is A. So 3 lots of apples would get me 3 apples, or 3A. Then we're going to take that 3 and we're going to multiply it by the 2. Okay, now you saw me circle this little operation here. That goes with that number every single time. So 3 lots of positive 2 will get me 6 as a result. Next one, and these will just build on from each other. We got 5 lots of 2C. Okay, so 5 lots of 2 carrots will get me 10 carrots. And then we've got 5 lots of positive 4. 5 fours gives me 20. All right. Question C again, we'll build on this one here. 2p times 6, or 6 lots of 2 pens would get me 12 pens. And then we take that 2p and multiply it by 3p. All right, so we've got p multiplied by p here. What I want you to do first is just look at the 2 and the 3. 2 3s, last time I checked, was 6. And then we can look at the p times the p, which is going to get us p squared to finish off. Okay, the reason we can do that, 2p times 3p, is exactly the same as writing this here. Because it's all multiplied together, there's no order that needs to be in. So I've taken care of the 2 times 3 to begin with, then I've taken care of the p times p at the end. All right. Question D, and this one is going to need you to consider some of these rules for multiplying and dividing integers, because it gets a little confusing at times, but this little table should get us through. Over onto D, it says 5 lots of 2e. Okay, so that's 5 lots of 2 elephants. That gets me 10 elephants. And then the next one I do is 5 lots of, not just 4, but 5 lots of negative 4. Okay, so the 5 is positive, but the 4 is negative. So when we multiply a positive and a negative together, okay, we actually get a negative outcome for our answer. So 5 lots of negative 4 will get me negative 20. We know it's a negative answer, then I just look at the 5 times 4 to get 20. The last one, something we haven't seen before, we've got a negative value outside here. So we've got a negative 3 times 5c. So a negative times a positive is going to be this one this time around, and that gets me a negative outcome. So negative, we know that to begin with. Then I can just look at the 3 lots of 5c, or 3 lots of 5 carrots, which is 15 carrots. Okay, then we move on to the second part, which is again that negative 3 times by negative 2. Now a negative times a negative is back up here, and it's the second rule there. Negative times negative is always going to give me a positive outcome. Now I can just focus on that 3 multiplied by the 2, which will get me 6. Okay, so these questions, go back, pause it, have an attempt at each of these questions, then we'll work through it if you want to, and don't forget our rules for multiplying and dividing positive and negative integers together.